the class, honestly. So we're going to look at the graph of a function. I'm going to call this f of x. I'm going to use 2 points on the function. This one has x coordinate. This one, so this is P and this is Q. P and Q are extremely close to each other, like this, P and Q. But if I graph them like this, I will not be able to show you anything. Now imagine that we zoom in. So P and Q close, very close to each other, very close to each other. So this has the x coordinate, x plus a little bit. This is a little bit, and it's denoted by lowercase h. So this is a tiny distance. From x to x plus h is the tiny distance h. Now, can anyone identify for us the y coordinate for P and also the y coordinate for Q? This is another very important concept, and we want to understand this. So can anyone, for when x is x, what will be the y coordinate? And when x is x plus h, what will be the y coordinate? Again, very important concept. Can anyone tell us what is this? And what is this? In other words, I'm saying x comma something, x plus h comma something. X coordinate, y coordinate, x coordinate, y coordinate. So can anyone identify the first one?
Is it x comma p?
So the function is denoted by f of x. So let's go back here. When we had 1, how did we get the 4?
You plugged in the 1
Awesome.
for the x squared.
Good. If x is x, how much is the y value then?
Four.
That is in the case with numbers.
Just y?
Yes, or what is the other way of expressing y? Excellent. There is another way of expressing y. I can write y, but I don't need y. But you're right, y is correct. But what is the other way of writing? The answer is right here. How did we determine the function value when x was 1 again?
You plug it into x squared.
Perfect. So we determined what? What is this exactly? How was it determined again?
I don't understand the question.
F of 1.
Plug the 1 into x squared. Okay.
So that's what we did. We determined f of 1. Remember how we read the function. F of the input equals the input squared plus 3. If you chose to put 1 here, it means that you put 1 here.
Right.
Excellent. So then, how do I determine this? If x is x, what is this?
Is it f of x?
Thank you so much. Perfect. Now here, this is very important concept. Awesome.
F of x plus h.
Thank you. It's the same thing, right? F of x plus h. Awesome. Yes, of course, we're going to draw this line passing through these 2 points. And we want to find the average rate or the slope of the line PQ. Can anyone dictate? and I would write the slope of the line PQ. We have the ordered
Is it
pairs. Yes.
f of x plus h minus f of x over h?
Yes, but let's see. It's everyone sees x plus h minus x, and you are correct. And this is what we calculated last time, that long expression, and this is extremely important. It has a name, and this is the difference quotient. Now the question is, what is the difference between this and this? So what is the difference between the average rate and the difference quotient? Here's the difference. This one tells me my average rate of change of the function between 2 points. This one gives us the same thing, the average rate of change of a function between 2 points, but these 2 points are extremely close to each other. They are not Baltimore and New York and 200 miles between them. No, they're extremely, extremely close to each other. So this is almost, not exactly. So coming back here, I wanted to say something else. So I go from Baltimore, I drive from Baltimore to New York, and you ask me, okay, what was your average speed if you used 6 hours of driving? No stops. I mean, I had stops, but I did not include the stops in the 6 hours. 6 hours was absolutely driving, nothing else. So this is what I got roughly. But if you ask me, what was your instantaneous speed when you were passing by, I don't know, Wilmington, Delaware? I will say, I have no clue. You have to call me. You have to call me at the instant I was passing by Wilmington, Delaware. I would have looked at my odometer and I would have said, I don't know, 55 miles an hour. That was my instantaneous, at that instant, speed. I would say it was 55. But if you don't call me and say, look at your odometer and tell me what is your speed, I won't be able to tell you the instantaneous velocity. But now, this is almost, not exactly, but very close, almost the instantaneous rate of change. That's the difference. The difference is here, I'm determining the average speed between 2 points far apart. Here, I'm determining almost the instantaneous rate of change at this point. What does that mean? This line, when I move Q closer and closer to P, this line from being a secant line, it almost becomes the tangent, which will give us the instantaneous rate of change. So please keep this in mind. This is very important, a very important concept we needed for chapter 1 and moving on from there. So that's why we were asked, if I remember correctly, it was f of x equals 1 over, I think, x plus 3 squared. We were asked to find, I'm going to abbreviate this as dq, difference quotient. So we were asked to determine the difference quotient for this function. And it took us a while because the algebra was heavy. So what are we trying to determine? Why are we trying to determine the difference quotient for this? In order to be able to find the instantaneous rate of change of a function. Almost. That's not exactly it. We're going to add something to it. Okay, and that's why you had, in one of the homeworks, you had to determine the difference quotient for another function, which was a quadratic function. Now, there are two things here. Difference quotient must happen. What must happen? Two things. Number one, all terms without h must simplify. And the second one that must happen is h from the denominator must simplify as well. Invent a function, please. Any function you want to work with. And let's determine its difference quotient. And show that these two will happen in this particular order. So give us any function you can think of, and we will find its difference quotient, as we discussed, f of x plus h minus f of x divided by h. What will give this? What will this give us? Almost the instantaneous rate of change of this function at any point, with some restrictions that we will discuss. So invent a function, please. Any function you want, and let's find its difference quotient. To illustrate that all terms without h must simplify, maybe I should write in the numerator. Also, h from the denominator must go away. So please invent any function you want to work with. Anyone? Can anyone give us a function so we can find its difference quotient? Any preference?
No. Can we do one with the radical?
Yes. Let's say 2x minus 1. Perfect. So we want to find the difference quotient for this function. I will copy the negative, the square root of 2x minus 1. Can anyone give us this for this function? And remember what we do? We analyze what the function is telling us first. And then we plug in x plus h. Can anyone tell us what to write here? Anyone, please?
Two x minus 1 in parentheses
We are looking
plus
for
h.
we are looking for f of x plus h. So first we analyze what the function is telling us. The function says f of the input is the square root of 2 times the input. What is the input now? In order to find f of x plus h, what is the input? Can anyone tell us the input?
It's x plus h, but I don't know what.
Good. So
How to
we,
input the two, yeah,
that's exactly how we did it all the time. It's the same method. There is no change. So we want to, the input is x plus h. So how do I write this?
what's the,
Any suggestions? How do we plug in this function x plus h?
Is it 2x plus h minus 1?
2x plus h. You have to say parentheses or you distribute. Which one? Do I use parentheses or you already distribute?
Well, why would you have to do either?
I'm sorry?
Why would you have to do either? Could you explain it? So I have 2x plus h minus 1, but what would you need to distribute? Distribute the 2.
Exactly. It's 2 times a sum. You either say parentheses or you distribute from the beginning. Which one is it? We have to decide.
Oh, okay, so if you distribute, it would be 2x plus 2h.
Excellent. Great job. Does everyone understand what we're doing here? Any questions? Is everyone with me? Because this is crucial. I mean, if we can continue if we have questions on this. Is this okay, everyone?
How did you come up with square root of 2x plus 2h minus 1?
If I replace this piece by x plus h, I have to replace this piece by x plus h, and it's multiplied. When I multiply 2 by a sum, I have to distribute 2 inside. Is that okay?
Can you just write it like over top of the radical small so like we can see just
So,
for visual?
f of x plus h equals the square root of 2 x plus, that's why I said we distribute from the beginning or we use parentheses. We cannot just write 2x plus h minus 1. That's why we have to make a decision. We either distribute from the beginning or we use parentheses.
Is one easier than the other, or does it really not matter at all?
This is the first step and this is the second step, but we can simply distribute 2 to 2 terms at this point without writing this step. It doesn't matter. If you want to write it, you can, sure. That's why I was asking. So when I heard 2x plus h, I was saying we either put parentheses or we already distribute. We cannot just write 2x plus h. We either put parentheses or we distribute from the beginning. So it means that we may still have difficulties with reading a function. So maybe we should just simply review this. So you understand in this function, if I'm asked to plug in f of x plus h, how do I write it? I'll come back in a minute. But we have to discuss this. It's not clear. Maybe it's not clear enough how to evaluate functions then. So can anyone give us, for this function now, f of x plus h? To make it super clear, because maybe it's not. Can anyone help with this?
X plus h plus 1.
Oh, this is not good. Good, perfect. And the denominator?
2x plus 2h plus 1.
That's it. Is this better? It's the same process as evaluating it for 0. It's still 0 plus 1 over 2 times 0 plus 1. It's the same thing. But this time, instead of 0, I have x plus h. Is this okay?
Can we go back and solve the first equation we were just working on?
You're talking about this?
Yeah, can we just finish solving that?
We're not solving. We are simplifying. Of
okay,
course.
I understand the simplifying.
Sure. That's why I wanted to make sure that this is clear. Yes. So let's continue. Perfect.